Hello, how you doing? It's Mr. Do the Math, and today we're going to talk about combining like terms, right? And so let's go over a few vocabulary terms. Does everybody have their paper or a piece of paper to take notes on?
Yeah.
Thank you. Right. A term is a piece, P-I-E-C-E, piece of a math sentence, piece or portion of a math sentence. Right? Terms are identified because they are separated by plus and minus signs. Right? So terms are separated by plus and minus signs. That's how you know you got terms present. Whenever you see a plus sign and a minus sign, you got terms present, right? Like terms are two or more terms that have the exact same variables and exponents, okay? So, like terms have the same variables and exponents. Alright, so what that means is if I got 5x and I got 3x, they have the exact same variables, so those are like terms. If I had 3x squared and 4x squared, exact same variables, exact same exponents. So if I had 4x to the third and 2x squared, these are not like terms because they don't have the same exponents. You feel me? All right, cool. All right, so next thing. Oh, I'm sorry, you should have wrote that down. Okay. Now, the coefficient is the number in front of the term, in front of the variable. Right? It's the number in front of the term, so variable. So if you have 5x, x is the variable, 5 is the coefficient, right? So when you combine like terms, what you're doing is adding or subtracting the coefficients, right? So when you combine, CLT, combine like terms, you're adding or subtracting like terms. So if we go back to these examples of like terms here, you got 5x and you got plus 3x. You don't add the x's, you just add the 5 and the 3. So it'll be 8x, right? And the same with this x squared. 3x squared plus 5x squared is 8x squared. This is what you do when you combine like terms, okay? Now, if there is a variable with no number, it is understood. This goes on that next line. If there is no visible visible coefficient, if there is no number in front of this variable, it's understood that a 1 is there. Okay? So if I had y minus 2y, I would get negative 1y, right? If I had f plus 3f, I would get 4f because I'm adding this 1f there. You feel me? We all on the same page?
Yes.
Okay, cool. All right. Now, let us look at this example here where we have a whole bunch of different variables, a whole bunch of different terms, right? We got the negative 7x. We got negative 7x. We got 3y. We got 8x squared. We have x squared y. We got negative y, 3x, 6x squared, xy squared, 7, negative 4x squared, and 2x. All right. There's one other row, but I don't want to put it there for the sake of time. So if we're going to put like terms in every section, this is what it looks like. So of all of these terms here, right, we're going to identify the like terms. We're going to put them together in these circles, right? So let's start off with this x. So we're going to put x's in this box here, right? can anybody identify a term, a variable that has, a term that has x in it? Yes, Marcella. Negative 7x is 1. Give me another one. Yes.
3x.
3x. So we got negative 7x, we got 3x. Any more? Yeah. 2x. Bam. Anything else? I'm sure it's another one on your paper. What's up?
X squared.
No. Oh, he said x squared. Is that a like term? No, because it's the second power. Right? Let's look at, so we got these. What about this 3y? So we're going to start with the 3y. Any more y terms? Anything with a y?
3y.
3y? Give me another one.
Can I carry it off the paper?
Yeah, what you got?
Negative 8y.
Negative 8y?
Yeah.
Yeah, negative 8y. So that's on your paper. On here, Alana, what you got?
Negative y.
Negative y. Good. Put negative 8y on yours because you guys got that on your paper. Good. Let's go to the next one. So we got our y's out the way. Let's do x squared here. So we got 8x squared. Is there another x squared term here? Yeah, Marcella.
X squared.
X squared. So that's gone. All right.
I got a question.
Oh, it's another one. Hold on. Let's get these on now. Avion.
Negative 4x squared.
Negative 4x squared. Good. What's your question?
So you see at the top and it say x squared and then we got a y behind it.
Yeah.
Is that together?
Yeah, x squared y is together. All right, good question. Let's do that one for this one. X squared y. So we'll put this one here. X squared y. Is there another x squared y term here? Not here. Not in this pile, right? All right, the next one we got a whole number. We got our constants. So we're going to put 6 here. Is there another constant here? Givens.
There it is, 7.
7. All right, 6 and 7 are gone. All right, and then in this last box, what are we going to put here? Yeah.
X plus to the second
xy
power.
squared, right? What's the difference between xy squared and x squared y? Yeah.
Yo x on it at the end and x squared y is in the
Very good. So here, x is squared, and here, y is squared. They are not like terms. You feel me? We good? And so now, we put all our like terms in these circles. The next thing we want to do is add them together. The next thing we want to do is add them together. So that's negative 7 plus 3 plus 2. Negative 7 plus 3 is what? Negative 4 plus 2? Negative 2x. That's what's going to be here, right? What about here? We got 3 minus y. That's 3 minus 1. 2y. Here we got 8 plus 1 minus 4.
8 plus 1 is 9 minus 4 is 5.
5x squared. This is that. 6 plus 7. 13. And then this is that. Okay? So basically what we did here is we identified like terms. And here we combined the like terms, huh?
You wasn't in the camera.
This in the camera?
Yeah, you
Okay.
just not in the camera.
Oh, that's all good. You can see my hand. Yeah, because that's supposed to be. Yeah, you combine like terms. All right? Now, let's actually do it as in a math problem. Let's do some math. Let's do the math. Here we go. Here we go. All right, so flip your papers over so we can see these math. All right, so let's look at some examples of combining like terms. All right, so number 1 is an easy one, right? So let's jump to number 2 where it says 4a minus 7a plus 2a. All of these are like terms because they have a as the variable, right? So all we have to do is combine, add the coefficients, add or subtract them. So it's going to be 4 minus 7, which is what? Negative 3 plus 2?
Negative 1.
Negative 1. So we're going to get negative 1a or just negative a. Any one of these is the answer. Okay? Let's look at this next one. We got negative 2x plus 9y minus 5x. help me out. What are the like terms in this particular problem? Yeah, Gibbons.
Negative 2x and negative 5x.
Negative 2x and negative 5x. So, when you're working out these kind of problems, what I would advise you do is to put either lines around, matching lines around like terms, and a different kind of line, like double lines or triple lines under a different set of like terms. Okay? So here we got negative 2 minus 5. Same sign, add, and keep. Good. So this is our answer. Negative 7x plus 9y. Now, when you're writing these things out, you want to put the variables in alphabetical order, right? X comes before y, so x comes first. Okay? And then you want to put the exponents in descending order. So you want to start with the biggest exponent and go down. You feel me? We all good? God bless you. All right. So let's go to this next one. 2b minus 8 plus 7b plus 5a. Like terms, Erie. What's the like terms? 7b and 2a.
I mean 2B, my bad.
7b and 2b. Yeah. Give me another set of like terms.
Me?
Gilmore.
A and 5.
Negative a and 5a. Y'all see that? All right, so then what we're going to do is we're going to do the math to the matching lines. So it's going to be 2 plus 7, 9, and then 5 and negative 1.
5 plus
5 minus 1, yeah,
4A.
4a. All right, so again, we're going to put a first, right? A first, b second. So 4a plus 9, okay? The next one, let's skip to number 6. So we got 9xy plus 4y minus 2yx. Now check this out. You got an xy here and you got a yx here. Xy and yx are the same, right? Because this is the same as x times y and y times x. And if these were numbers, you'll still get the same answer. You good with that, Nevaeh? Okay. Yeah. All right, so look, these are the same. So what you want to do is, for the sake of preventing confusion, just rewrite this. So it's going to be 9xy plus 4y minus 2xy. Okay? Now, these are the like terms. And you do the math. 9 minus 2, 7xy plus 4y. That's it. Okay? The next one. Dos aquí más 8y. 2x plus 8y. 2x plus 8y. Where are the like terms? There are none. This is your answer. Since there are no like terms, you can't do any math. All right? If there are no like terms, you can't do any math. Okay? All right, let's do this last example and then we're done. 4x squared minus 2x plus 6 minus 3x squared plus 1. All right, new voice. This is easy. Give me a set of like terms.
3x and 2 and 4x.
All right, 3x squared and 4x squared. Good. Give me another set of like terms. Go ahead, Amiri. 6 and 1. Anything else?
No.
That's it. All right, so let's do the math. So we got 4 minus 3, 1. So it's x squared. So then we got, there is no like terms with this 2x, so it comes straight down. Minus 2x. And then we got 6 plus 1.
7.
Plus 7. That's it. No more like terms. You're done doing the math. Okay? So that's how combining like terms works. Right? Remember, a term is a piece of a math sentence. The like terms have the exact same variables and the exact same exponents. Okay? So, If you haven't already, don't forget to like and subscribe. If you have any questions, comment below. Mr. Do the Math out.
Can I get my phone back now?